Welcome everybody. Today we're going to continue thinking about our model for rotational motion by extending the idea of free body diagrams. So if I think about an object that I have suspended from a string here, I can draw sort of an ordinary free body diagram for such an object by simplifying it down to a really simple picture and representing the different forces that are acting on the object. For something like this, I might think about there's a tension force pulling upward and there's a gravitational force pulling downward, and I would label all of those as we're used to. Force maybe on the tube by the earth, and then there would be a tension force on the tube by the rope. So this might be what we would draw in the regular translational motion part of the course. Now that we're thinking about rotational motion, I could think about, well, what if I had a situation where I now wanted to move this over here and hold it up by pushing on it like this. And now the situation gets a little bit more complicated. I could still draw a regular free body diagram like this, but it won't capture the full richness of the picture. And so what we're going to draw instead is something called an extended free body diagram, where rather than representing the object very simply like this, I'm going to represent the object a little bit more like what it really looks like, still simplified to make my life as easy as possible. I'm drawing it tilted because I'm doing a situation where I have pushed on it a little bit and it's hanging like that. And then I want to not just represent all the forces as acting on the center of the object, but I want to actually show you where each force is acting on the object. So I have three forces acting on this object now, the same two forces that I had over here, plus an extra force that I am acting on the tube to push it so that it is like that. And again, I'm going to try to represent each force in the actual place that it acts. So the tension force is acting up here. So I'd have a tension force still on the tube by the rope. I'll have a gravitational force still. Now gravity's a little bit strange because it's a non-contact force. So there is no place that it acts on the object. So we can instead draw this force as if it were acting on the center of mass, which for something as simple as this tube is going to be right in the middle of the object. So here I would have a gravitational force, again, acting on the tube by the earth. So the only difference so far is these forces are now shown acting at the location where they are. I'm also adding a new force here. I'm going to imagine that I'm actually pushing somewhere near the bottom of this thing, so not necessarily on the middle, but somewhere near the bottom. And I, of course, am acting a normal force on this tube. So I'm going to say that this is acting down here is the point of contact, and it would look something like this. So this would be a normal force on the tube by me. And so now I have all the different forces represented, not just in the abstract, but where they are actually acting. This will then make it easy for me to measure the distances that I need to make further steps in our model for angular motion.